Hello friends, welcome back to my YouTube channel Soil IQ. I am Dr. Bhavani Prasad Mondal, working as an assistant professor cum junior scientist in Department of Soil Science, Bihar Agriculture University, Savor, Bhagalpur. So we all know that the ICAR JRF and SRF examination is just one day away. So this is the time for last minute preparation and last minute revision. For this, I made this video for our beloved students who are the aspirants of ICAR JRF and SRF examination 2026, and this is for soil science subject, and this is helpful for your rapid revisions in this subject. So let's begin. Starting from very fundamental branches of soil science, that is soil pedology. Let's start. Multiple choice questions. I have given multiple choice questions like number one, who is known as the father of soil science? This is very easy basic questions to you. That is the Dokuchev. Answer is B. That is Dokuchev. Dokuchev is known as father of soil science. Number two, soil is formed primarily from. That is from the, what will be the answer? Answer is B. That is weathering of rocks. Now coming to the third questions, which branches studies soil in relation to the crop growth? Okay, so there are this thing, answer will be edaphology. Edaphology is the study of soil science in relation to the crop growth or plant growth. Okay, so I have formulated all these questions starting from very basics to the advanced level. Now coming to fourth question, soil formed at the place of origin is called, with the soil which is formed at the place of origin, that soil is known as sedentary soil. Answer is B. Okay, and the soil which is formed due to transportation by different agents like water, air, so that is called transported soil. Now fifth question is, which mineral is most resistant to weathering? So many times in JRF this question came. So answer is quartz. Quartz is the most resistant mineral and it's also a primary mineral. Okay, and most abundant mineral is the feldspar. Okay, please remember these things, and this is important for JRF. Then another sixth question is, which mineral is least resistant to weathering? Okay, can you guess? See the answer. Answer is C. That is the calcite. Sometimes the option olivine is also there, but here the option is calcite. Okay. Now next one is the marble is formed. Okay, so transformation of one form to another form of rock. Okay, means igneous to igneous, sedimentary to metamorphic rock. That is very important for your JRF and SRF examination. So marble is formed from, you know, all limestone. See, then quartzite is formed from, you all know, that is the sandstone. So my dear students, please, this conversion from igneous and sedimentary to metamorphic rock, please remember this sequence. Okay, then next question is, which element is present in highest proportion on the earth crust? Okay, so you all know the highest proportion, which element? That is the oxygen. If it is that oxygen, silicon, aluminum, if it is telling which metal is most abundant, then answer will be aluminium. Okay, then you see solam. What do you mean by solam? There are different horizons. So A and B horizon togetherly known as soil solam. Then you see, what is regolith? Regolith is A horizon plus B horizon plus C horizon. So answer is C. Then the what is R horizon represent? Okay, R horizon represent, that is the organic matter, weathered rock, hard bedrock, topsoil. You know, so R is the hard bedrock. So answer is C. Now one liner from the pedology portion, that who is known as the father of soil science? That is Dokuchev. Who is the father of modern soil science? This is very important. That is Hans Jenny. Which is the most resistant mineral? Quartz. Least resistant mineral? Calcite. Okay, so that stability series also, please see stability series given by Goldrich 1 and their Jackson series. So please read this series very carefully. This is suggestive type. Then most important chemical weathering is hydrolysis. Hydrolysis is also known as double decomposition process. Okay, so chemical weathering is important. Washout horizon is E horizon, also known as alluvial horizon. Was-in horizon is the B horizon. This is also known as alluvial horizon because whatever the materials that get deposited in this horizon. Again, solam is A plus B horizon, regolith A plus B plus C horizon. Top organic horizon is O horizon. Okay, sometimes it is mostly present in the forest soil. Parent material belongs to C horizon and bedrock belongs to the R horizon. Then coming to the soil physics. Okay, in soil physics, what is soil structure? Soil structure refers to the arrangement of which option? This is the number C, primary soil particles into aggregates. Second question, which structure is most suitable for root growth, or it may come which soil structure is suitable for the agricultural crop production? Answer is same, that is the granular soil structure. Next question is, platy structure is commonly found in, see, surface soil, subsurface compacted soil, sandy soil, and peat soil. Platy structure is found in which type of soil structure? Soil, sometimes students become confused. Answer is the B, that is subsurface compacted soil, because platy structure there should be the compaction. So, okay, subsurface layer there will be compaction. That's why platy structure mostly found in subsurface compacted layer. Which structure is the characteristics of the B horizon? See, these are the very important question, and often students get confused. See, the answer is the prismatic structure is the characteristics of the B horizon, alluvial horizon. Next question is, the columnar structure is commonly associated with which soil? We often get confused with it will be saline soil or sodic soil. A or D will not be the answer. Acid soil, no. Saline soil, sodic soil, laterite soil. Laterite soil will also be no. So which will be the option? Saline soil or sodic soil? See, this is the sodic soil. So this is one of the important question and often confusing by the students. So columnar structure is commonly associated with the saline, not saline. This is the associated with sodic soil. Then columnar structure develops mainly due to, for what? You know, this is due to excess of sodium. Then another question, which structure is best known as cookie crumb structure? Means sometimes it is called honeycomb structure is also told, that is found in the cookie crumb or granular structure. Granular structure is common in which type of soil? You see, grassland surface soil, there is G for G, that is grassland surface soil has the granular soil type structure. So then next question, which structure is produced due to shrink swell of clay? Answer is the angular blockage. Due to swell shrink nature, which structure is produced? That is the angular blockage. Then coming to the number 10 question, according to the USDA, which should be the particle size for sealed particle? See, answer will be B, 0.052, 0.002. Less than 0.002 is the clay particle. Then it is same for ISSS and USDA, that is less than 0.002 millimeter for clay particle. For sealed, it is 0.0022 to 0.02 for ISSS, USDA 0.05 to 0.002, and this is one of the most important question for ICAR JRF. Then coming to the clay particle size, okay, already I told that is less than 0.02 millimeter, and color is determined using what? USDA chart, moon cell color chart. You all know answer will be the moon cell color chart. Then hue indicates what? Soil color indicates by hue value chroma. So hue indicates what? Dominant wavelength. Now coming to chroma. Chroma represents, that is the purity of the color. Okay, so please remember this is important again for JRF, SRF also. Then plasticity. What is plasticity? Plasticity is the capacity to change shape under any external pressure. Okay, so answer is B. What is consistency? Consistency is the ability of the soil to resist the change under any external force or pressure. That is the ability to resist, or this is the capacity to change. This is the fundamental difference between consistency and plasticity. Okay. Then soil colloids particles are generally smaller than 1 micron. Okay, this is also important. Okay. Then coming to maximum density of water occurs at what temperature? You all know, you have studied in class level exam, that is 4 degrees Celsius. Then surface tension of water at 25 degrees Celsius. This is very important questions. Okay, that is surface tension of water at 25 degrees centigrade is 72.79 per centimeter. Then coming to the bond angle in water molecule is, what will be the answer? Yes, correct. That is the C, 104.5 degrees Celsius. Then hygroscopic water is held at a tension, what? Yes, B, more than 31 atmosphere or 31 bar. The water held by small particle, that is known as hygroscopic water. Permanent melting point, that is at 15 atmosphere or 15 bar. Okay. Available water is held between between 1/3 bar to 15 bar, means between field capacity to permanent wilting point. Okay. Then movement of soil water follows which laws? You all know, that is the Darcy's law. Then soil air contains approximately how much time more carbon dioxide than atmospheric air? Because in soil there are so many of microbes. That's why 10 times more carbon dioxide. Soil air contains 10 times more carbon dioxide than atmospheric air. Okay. So diffusion of gases in soil follows which law? You all know, that is the Fick's law. Heat transfer occurs mainly through, this came in ICAR JRF in 2013. This question came that heat transfer in soil mainly occurs through which process? That is the conduction, because it is solid medium. Radiation without any medium, convection mainly the liquid medium, and conduction is a solid medium, and evaporation, that is the just conversion from water to vapor, from that maybe happen from water body to soil to any surface. So conduction is the answer. Okay. Now coming to soil physics rapid revision, that is water has maximum density at 4 degrees Celsius. Surface tension of water at 25 degrees Celsius is 72.79 per centimeter square. Bond angle of water molecule is 104.5 degree. Water molecule has a tetrahedral arrangement. Please remember this. Available water lies between field capacity and permanent wilting point. Field capacity means that is the potential at field capacity is approximately minus 1/3 bar, or minus 1/3 atmosphere, or minus 33 kilopascal. Permanent wilting point is minus 15 bar, or 15 minus 1500 kilopascal. Hygroscopic water is held at more than 31 bars. Hygroscopic water is unavailable to the plants. Capillary water is the main source of the plant water. Gravitational water hold below 1/3 bar, below field capacity. Water movement in saturated soil follows the Darcy. So these questions also came in ICAR JRF examination. Water moves from higher potential to lower potential, and soil water potential always denoted as negative, and suction always denoted as positive. And total soil water potential is a summation of metric potential, gravitational potential, osmotic potential, and these are the potential, main potential, which are denoted as total soil water potential. Okay, and concept given by Buckingham. Then see soil moisture measurement. Tensiometer measures the soil metric potential. Tensiometer works up to 0.8 bar, means 80 centibar. Tensiometer is most useful for irrigation scheduling. Neutron moisture meter generally measure the volumetric soil water content. Okay, whatever the indirect measure of soil water measurement is there, those are mainly measuring the volumetric soil water content. And in nutrient moisture meter, that is important questions, which are the source of neutron, that is, you see, that is the radioactive source, americium and beryllium. These are the source of first neutron. What are the speed? I have not mentioned, but I'm telling what are the speed of first neutron, that is 1600 kilometer per second, first neutron. Okay, and then energy is 2 to 4 mega electron volt, and when it gets collide with the hydrogen nuclei, then it gets thermalized. And what will be the speed of thermalized neutron? Then only speed is 2.7 kilometer per second. And if and what is the energy? That is 0.03 electron volt. Okay, so please remember all these things for the neutron moisture meter. Okay, so then hydrogen content is directly related to the soil moisture. Time domain reflectometry is related to the electromagnetic waves that help to measure the soil moisture. Frequency domain reflectometry is also used to estimate the soil moisture, and gravimetric method is the standard method, but it is a destructive method. We cannot use that soil sample again for further analysis. And oven drying is done at 105 degrees Celsius for 24 hours, above which, if we do the oven drying, the structural water from the soil comes from. That's why the temperature for oven drying is 105 degrees Celsius. Then ODR, critical ODR, this is most important for JRF for most of the crop plant, that is 20 to 10 to the power minus 8 gram per centimeter square per minute. Optimum ODR is 13 to 10 to the power minus 8 gram per centimeter square per minute. ODR means oxygen diffusion rate. ODR indicates the aeration status of the soil. It is measured by platinum electrode technique. Very, very important. And who gave platinum electrode technique? That is Lehmann and Erickson, 1952. This is important for also SRF. Poorly aerated soils indicate what? That is low ODR value. Waterlogged soil generally have low oxygen diffusion, means low ODR rate. Soil air contains about 10 times more carbon dioxide than atmospheric air. Soil air contains less oxygen than atmospheric air. Gas movement in soil follows the Fick's law. Ideal soil pore content 2/3 of water and 1/3 of air. This is very, very important for SRF and also for JRF. That ideal soil pore content 2/3 of water, mostly water, then air. Good soil adhesion promotes the good root respiration. Then soil temperature, heat transfer in soil occurs mainly through the conduction. Already I told heat conduction follows the Fourier law. Sandy soil warm up faster than clay soil. Please remember, sandy soil warm up faster than clay soil. Wet soil warm more slowly than dry soil because the dielectric constant of water is high. Dark colored soil absorb more heat than light colored soil. Specific heat of water is 1 calorie per gram per degree centigrade in CGS unit. Then soil texture, USDA recognizes 12 textural classes that question came in ICAR JRF 2014. Sand particle size, that is the 0.05 to 2. Silt is 0.05 to 0.002. Clay particle less than 0.002 millimeter. All these three are according to USDA, United States Department of Agriculture. Soil texture is a permanent property. Texture cannot be changed economically under the field conditions. Okay, because we cannot easily change the soil texture. Soil structure, granular structure is best for agricultural crop growth. Platy structure restricts the root growth. Columnar structure is the characteristic of sodic soil. Again, I am repeating, it is a characteristic of sodic soil. Blocky structure commonly found in the subsoil layer. Such structure describe grade class type, GCT. Then soil density, particle density is the common value is 2.65 megagram per meter cube. Bulk density of the cultivated soil varies from 1.1 to 1.6 megagram per meter cube. High bulk density indicates soil compaction. Porosity decreases at bulk density. Obviously, there is an inverse relation between specific volume and bulk density. Total pore space is calculated from bulk density and particle density. Then coming to soil colloids, particles smaller than 1 micrometer. Clay and humus are the major soil colloid. And soil colloids possess higher catenation capacity. Humus has the highest CEC than any clay mineral. Then important instrument, pycnometer used for measuring particle density. For measuring bulk density, we use core sampler. Pressure plate apparatus is used for measuring soil moisture constant. Pressure membrane apparatus for measuring higher moisture tension. Tensiometer used to measure metric potential of the soil. Neutron moistometer used to the volumetric water content of the soil. Infiltrometer measures the rate of water infiltration into soil. And platinum electrode technique used for measuring oxygen diffusion rate. Then coming to the manures and fertilizer, this portion is very important. That is, bulky organic manures are characterized by low nutrient content, and it should be applied large quantities because nutrient content is low. Well decomposed farmyard manure content, this is important question for JRF. That is the 0.5% nitrogen, 0.2% P2O5 and 0.5% K2O. Then coming to which chemicals are commonly added to the FYM to reduce the nutrient losses. You see, gypsum and superphosphate is used to reduce the losses. Okay, in the first crop, approximately what percentage of nitrogen from FYM becomes available? You know, that is the 30%. Most important question for SRF. Then night soil refers to what? Human excreta in both in solid and liquid form. Which of the following contain highest nitrogen according to given option? You know, that is the night soil. It has highest nitrogen. Earthworm cast generally contain comparatively higher availability of what? It also contains phosphorus, calcium, potassium. So all of the above. The most important green manure crop is what? Sunhemp. Then which of the following is an introduced as green leaf manuring plant? That is the Gliricidia. Then which one of the following is a non-edible oil cake? That is the castor cake. Which of the following classified as a high analysis fertilizer? You know that high analysis fertilizer means which fertilizer contain the nutrient more than 25%. That is high analysis fertilizer. Here only urea, that is more than 46% nitrogen. So it is a high analysis fertilizer. Fertilizer grade refers to the minimum guaranteed nutrient content expressed as N, P2O5 and K2O. Then which fertilizer contains the highest percentage of nitrogen? That is anhydrous ammonia, 81% nitrogen. Deep placement of nitrogenous fertilizer is essential for what? That is for lowland rice. Okay, to minimize the loss. Which fertilizer application method is best suited for wider spread crop like sugarcane, cotton? That is the band placement. Which of the following is nitrification inhibitor? That is the NSAR or nitropyrin. Quick fact: most concentrated nitrogenous fertilizer anhydrous ammonia. Most concentrated solid nitrogenous fertilizer urea. Oldest commercially available phosphatic fertilizer, important for JRF, single superphosphate. Most suitable fertilizer for fertigation, that is potassium nitrate. Again, it is important question for JRF and SRF. Potassium nitrate. Only organic nitrogen fertilizer among chemical fertilizer. Urea. Urea is a organic fertilizer, but it is not used in organic farming because it is a synthetic fertilizer. Ferty seed drill is mainly used for drill placement. Deep placement minimize nitrogen losses in lowland rice. Foliar spray is recommended when quick correction of the nutrient deficiency is required. Quick action through foliar spray. Neem coated urea act as both as a slow release nitrogenous fertilizer and also as a nitrification inhibitor. This is also important for especially for SRF and also for JRF. Then coming to plant nutrients, most of the time question coming from here, nutrient deficient symptom in all types of ICAR examination. How many elements regarded as essential? You all know that is 17 elements. Which element has the latest edition, that is in 1987, that is nickel. Okay, then which scientist proposed the criteria of essentiality? This is important for JRF, Arnon and Stout, 1939. Then which nutrient is the central constituent of chlorophyll? You know, magnesium. Then which nutrient is essential for nitrate reductase and nitrogenase enzyme? That is the copper. Molybdenum is the nitrate reductase and nitrogenase enzyme. Whiptail disease of cauliflower is due to the deficiency of what? Molybdenum. Then Khaira disease of rice is caused by the deficiency of what? Zinc. Then which deficiency causes blossom end rot of tomato? That is calcium. Then whip-like appearance in terminal leaves due to the deficiency of boron. Then leaf bleaching in sugarcane is caused due to deficiency of iron. Marsh disease of pea is caused due to deficiency of manganese. White part of maize caused due to deficiency of zinc. Then some quick fact, that is the plant contains more than 90 elements. 17 elements are considered as essential. Nickel is the latest added element. Primary nutrients are N, nitrogen, phosphorus, potassium. Secondary nutrient calcium, magnesium, sulfur. Micronutrient cations are zinc, copper, iron, manganese, and that is nickel also. And anions are boron, molybdenum, chlorine. Arnon and Stout 1939 proposed the criteria of essentiality of nutrient. Nitrogen is taken in both form, ammonical form and nitrate form. Phosphorus is absorbed as H2PO4 minus, potassium absorbed as K plus, calcium as Ca2 plus, magnesium as Mg2 plus, sulfur is SO4 2 minus, iron is Fe2 and Fe3 plus, and molybdenum is O4 2 minus. Then some other facts: magnesium is the central component of chlorophyll, potassium regulates osmotic balance, calcium maintains cell membrane integrity, iron is essential for electron transport, molybdenum is a component for nitrate reductase, nitrogen deficiency appear in older leaf, iron deficiency appear in the younger leaf, calcium deficiency in terminal portion, potassium deficiency causes the leaf scorching, phosphorus deficiency causes the purple leaves, zinc deficiency Khaira disease, boron deficiency internal necrosis of amla, and molybdenum deficiency cause whiptail of cauliflower, calcium deficiency cause blossom end rot of tomato, and hidden hunger, yield reduction without any visible symptom. Then coming to soil chemistry, this is very, very important. That is the term colloid was introduced by Thomas Graham. Goldsmith's first law is related to what? That is the isomorphous substitution. Then Goldsmith's first law permits isomorphous substitution when ionic radii differ by 10 to 15%. The permanent charge of soil colloid is mainly due to isomorphous substitution. The pH at which the net surface charge of colloid becomes 0 is called 0-point charge. Then the 0-point charge of wet height is approximately 8.5. This is very important. Increasing soil pH generally results in higher CEC. When pH will increase, CEC negative charge increase, and also the CEC will increase. Which electrokinetic phenomenon involves movement of colloidal particles towards an electrode? That is the electrophoresis. Very, very important for ICAR SRF examination and also for JRF examination. According to the lyotropic series, which cation is adsorbed most strongly by the soil colloids? This is important. The answer is D, cesium. Which clay mineral has predominantly pH dependent charge? That is the C, kaolinite has pH dependent charge. Montmorillonite has the permanent charge. Thickness of diffuse double layer, this is diffuse double layer, again important, decreases with increase in electrolyte concentration, increase in temperature, increase in valence of counterant. So answer is all of the above. Please remember, this is very important for SRF and also for JRF. Friend-Lewis adsorption equation assumes what? That the no adsorption maxima. This also important question, that which equation, Friend-Lewis equation, cannot assume that there is no adsorption maxima. Then one-liner fact, father of soil chemistry, Thomas Graham, soil colloidal size is less than 2 micrometer, true solution is less than 1 nanometer, colloidal particle is 1 nanometer to 1 micrometer, suspension is more than 1 micrometer. Please remember the size. Higher soil pH means higher negative charge, higher CEC. Higher zeta potential means there will be greater dispersion between particles. Lower zeta potential means flocculation of the particle. And humus has the highest CEC, that is 200 to 250 centimole proton per kg or more. Permanent charge due to isomorphous substitution. Variable charge developed due to pH dependent charge. Goethite ZPC 8.5, gibbsite ZPC 0. Charge is more than 9, silica ZPC is 2. Kaolinite has mostly the pH dependent charge. Montmorillonite has a predominantly permanent negative charge. Electrophoresis what? Movement of colloidal particles. Electroosmosis, movement of water. Streaming potential, pressure generates an electrical potential. Donan membrane, selectively permeable membrane. Goldsmith's first law describes isomorphous substitution, and Goldsmith's second law describes the radius ratio law and coordination number. Very, very important. Then coming to soil microbiology, this is the last one. Which microorganism is known as natural genetic engineer? That is the Agrobacterium tumefaciens. Then next question is which organism is the ecosystem engineer? That is the earthworm. Then which organism is responsible for producing the characteristic of smell after rain? That is actinomycetes. They produce geosmin. Earthworms are particularly rich in nitrogen, phosphorus, and calcium. Which bacterium fixes nitrogen under anaerobic conditions? This is important. This comes in net examination of ICAR, I think. That is the Clostridium. Which free living nitrogen fixing bacterium grows best in neutral soil? Answer is Azotobacter. Which nitrogen fixing tolerate the high acidic soil condition? That is the Beijeringia. This is again important. Nitrogen fixation in blue-green algae occurs in heterocyst. The term rhizosphere was coined by very important Hildner, okay, who is regarded as the father of soil microbiology. That is the SN Winogradsky. So all the best. Today's class is up to this, and I wish very all the best for to the all aspirants of ICAR JRF and SRF examination. And stay confident, stay focused, and give your best in the examination. See you in the next video. And up to this, if you like my video, please like, subscribe my channel. And again, all the best for your examination. Thank you. See you again.